Hi everybody. Today I'd like to go through this question, which is a question about set theory and particularly set notation. So we start off with these two sets, A and B. A has the elements A, C, D and E, and B has the elements D, E and F. And we're just looking inside this universal set, which just has the elements A, B, C, D, E and F. So we could draw this as a Venn diagram, and most of the things we're trying to work out, we could use the Venn diagram to work out, or we could write them out algebraically, whichever you're more comfortable doing. So I could draw our universal set, I already have in fact, in this Venn diagram over there, and then inside that we could mark each of these sets. So A I might mark in purple. So A is A, C, D and E, A, C, D, E, E. There we have A. And B I'll mark in green so we can see it, D, E and F. There we have B. So most of the things you want to do we could do from the Venn diagram or algebraically. So let's start. First thing we want to find is A minus B. So that's the set containing everything that's in A but is not in B. So it's the set. We only want to include elements that are in A, but the ones that are not in B. So A is okay, C is okay, but D is here and so is E. So we'll have A and C. And we could have seen that quite easily from the Venn diagram. We want everything that's in purple but not in green. So it's just A and C. Okay, and then similarly we have B minus A, so we want everything that's in B but not in A. So we want everything that's in green, but not in purple. So we could do it looking at this, or we could do it looking at this. Let's look at the Venn diagram this time. Everything that's in green, but not in purple. So it's in here, but it's not in purple. That just leaves us with F. Okay. The next thing we want is A union A union A complement. So A, everything in A, union everything not in A. Everything in purple, union everything not in purple. So that's going to be the whole of our universal set S, which is A, B, C, D, E and F. And you can write it either way, as S or as our set braces with the elements A up to F. Okay, so that was fairly quick. The next thing we have is this one here. This time we have an intersection. So here we want everything that's in B and everything that's, and also not in B. So we want everything that's in this green, that's B. Things outside B are B complement. So everything that's in B and not in B, there's nothing. Always B intersect its complement is going to be the empty set. Can't have anything in a set and not in the set. Okay, we have another union one here. This time we want A, everything that's in A, or the complement of B, or possibly both. So we could look at it in terms of the Venn diagram, but let's look at it in terms of the set elements. So to be in A, that means it's one of these things, A, C, D and E, or it's in the complement of B. B was these three things, our green elements, so the complement outside that will be A, B and C. Not a very good braces, is it? Never mind. So everything that's in one or other of both of these, A, B, C, D and E. Okay, could have done that using the Venn diagram too. How about this one? This time we have A union B and then we take the complement. So we need to do the union first and then take the complement. We could do it up here. A union B is everything in one or both, everything that's in green or purple. Then when we take the complement, we get everything outside that, just got B. Or we could write it down algebraically. What's A union B going to be? That's going to be A, C, D, E and F. That's it, and then we take the complement. Everything in our universal set, that's not one of those. The only thing left over is B. Well, that in fact was part G, not part F. So now we'll do what is hopefully the real part F. This time we have A complement intersect B. So everything that's in A complement, so outside A, outside the purple and inside the green. We could do it algebraically or we could do it from the Venn diagram. Outside the purple, we've just got B and F. Inside the green, we're left just with F. Okay, and finally the last one, we have the complement of A intersect the complement of B. So we just want the elements that are outside A and outside B, outside the green and outside the purple. So outside the green and outside the purple, the only thing we have left is B. Okay, there you are.